Okay, in this video we're going to talk about Unit 9, Objective 5, Euler's method. What Euler's method is it's a way to approximate the value of a function given its differential equation and some point on the function. It's not a very difficult process, but there are quite a few steps involved. So we're just going to run through an example, kind of show you what Euler's method is about, and then we'll call it quits on the video. So we're going to see a problem that would look something like this. It'll say estimate f of 2.6 using Euler's method with steps of 0.2 if dy dx, so there's our differential equation, equals x plus y, and f of 2 equals 0. So they're going to give us that differential equation, x plus y. They're going to tell us that there's some point on the curve that we're looking at, 2, 0. And they want us to estimate f of 2.6. So we're not going to want to go through all the steps of solving that differential equation and then finding out what the function is and then plugging in 2.6, because on a question like the one we have now, we actually can't solve that differential equation. Because if you were to try to solve that differential equation, you would get something like negative y plus dy dx equals x. So when you go to multiply by the dx to move it to the other side, we would end up with something like this. And that negative y dx, we can't really do anything with that. That's a problem. We can't really solve it. So we have to be able to estimate our 2.6 in another way. So instead of trying to figure out what the function actually is, we're going to kind of go around it, mess around with the slopes, and try to figure out what the y value would be from there. So if we're going to use Euler's method, we need to construct a table, and the table is going to start out the same every time. So on our table we're going to have 5 columns. The first column is just going to be some point xy. The next column is going to be dy dx. For our particular problem here, that's x plus y. That's going to change depending on your problem, obviously, but in this case it's going to be x plus y. The next column is going to be delta x, so don't forget that delta x just means the change in x. Our next column is going to be delta y. And how we're going to find delta y is we're going to take dy dx and we're going to multiply it by delta x. So your delta x and your dx are going to kind of cancel, because that d in dy dx is the same thing as delta. So we're going to end up with just our delta y, or our change in y. And then our last column is going to be another point. It's going to be x plus the change in x, comma y plus the change in y. So this column is going to be set up, this table is going to be set up every time you use Euler's method. And the steps are always going to be the same, except it's going to be different numbers because your slope field is going to be, or your differential equation is going to be a little bit different each time. But what we want to do is, we know we're starting at the point 2, 0. So we're going to say 2, 0. Then we look at the next column. It says, well, what's the rate of change? What's dy dx at that point 2, 0? Well, in our problem, dy dx is found by x plus y. So we're going to take our point xy, say 2 plus 0 is 2. So our change in y over change in x, our derivative, our slope, whatever you want to think about it is, at the point 2 is 2. Delta x, they tell us in the problem, they say use Euler's method with steps of 0.2. That's how x is going to change. So delta x is going to be 0.2. Then to find delta y, we want to take our derivative from that second column, in this case 2, multiply it by our change in x, in this case 0.2, and we're going to get a change in y of 0.4. So we now know that if we change the x value of 2 by 0.2, we're going to be at the point 2.2. And if we change the x value by 0.2, it turns out that our y value is going to change by 0.4. So 0 plus 0.4 is 0.4. And that's basically Euler's method. We just have to keep repeating the process until we get to the point that they asked us to find. So right now we're at the x value 2.2. We need to get to the x value 2.6. So we need to repeat the process. So if we start with 2.2, comma 0.4, our slope, our dy dx, or in this case x plus y, is going to be 2.6. Multiply that by delta x is always, for this problem, going to be 0.2. So to find delta y, we multiply 2.6 by 0.2 and we get 0.52. And then we add our delta x and our delta y to the point that we started with. So we're going to be at 2.4, comma 0.92. So we're not quite where we want to be. We want to be at 2.6. We're at 2.4 right now, so we're going to do it again. So we're starting at 2.4, comma 0.92. If we find the slope there, we add those things together, we're going to get 3.32. Our delta x in this case is always 0.2 because they tell us the change in x is 0.2. To find the change in y, we're going to multiply dy dx by delta x and get 0.664. And then we add the change in x and the change in y to the x and y values, and we get 2.6, comma 1.584. So we have approximated 2.6 using Euler's method, and we get approximately 1.584. So f of 2.6 is approximately equal to 1.584. So Euler's method, pretty straightforward. It can be a little tedious depending on how many times you have to do this process. But pretty straightforward. We'll call it quits on this video. See you in the next one.